Good evening. So this is the balancing problem for rotating mass. So in this problem, the data are 4 masses M1, M2, M3 and M4 are 200 kg, 300 kg, 240 kg and 360 kg respectively. The corresponding radius of rotations are 0.2 meter, 0.15 meter, 0.25 meter and 0.3 meter respectively. And the angle between the successive masses are 45, 75 and 135 degree. So find the position and magnitude of the balanced mass required if it is radius of rotation is 0.2 meter. So the last line, if it is radius of rotation is 0.2 meter, it is for balancing mass. So initially, there are two methods to solve this problem. One is analytical method and graphical method. So mostly we are going to solve in the graphical method. So only one problem I am going to discuss about the analytical method, how to solve this problem. So in engineering mechanics itself, we have studied if any forces is acting in an inclined plane, we have to consider it as two component. One is horizontal component and another one is vertical component. Because it is very easy to find out. And in analytical method, just initially I taken horizontal component of forces. So for that, we can understand this balancing mass diagram. So initially there is an horizontal mass for the reference one. So from this, the 45 degree, the another mass is acting, that is M2. So from this, we have to draw a line at an angle of 45 plus 75 degree, 120 degree. So from the base, from the reference line. For the fourth mass, that is 255 degree from the reference plane. So initially we have to draw this inclination or balancing diagram. So after this diagram, we have to calculate by analytical method. So the horizontal component of all the forces, the first mass M1 R1 into cos theta plus M2 R2 into cos theta 2 plus M3 R3 cos theta 3, M4 R4 cos theta 4 for horizontal component. So from this we can obtain the value of 21.6 kg meter, and now the vertical component we have to solve, that is sum of all the vertical forces M1 R1 sin theta 1. So why we have to substitute the sin theta is, it is an vertical component. So for the vertical component we are using sin, for horizontal components we are using theta, so cos. So the sum of vertical forces is 8.5 kg meter. So the resultant of two components is square root of sum of h square plus sum of v square. So finally we can get R value, that is 23.2 kg meter. So we know very well that the centrifugal force is m or omega square. If you are balancing two position, the omega will be cancelled because the omega is constant. So m into r finally we get, so that is 23.2. So from the resultant value, so from this m r equal to 23.2, we can get the m value for the balancing mass. So tan theta is equal to sum of v by sum of h. If you know the theta value, then only the balancing mass position we will get. So for that, in this problem, the theta value is 21.48. For the balancing, we have to put this balancing mass in the opposite direction, that is 180 degree apart. So for that, 180 degree plus 21.48, finally we can get 201.48 degree. So this is the another method, that is the graphical method. The same inclination position space diagram we have to draw. So initially the M1 is in horizontal, so that is a reference plane. So from this 45 degree and 120 degree from the horizontal component and the 250 degree for the balancing mass. So finally we are going to draw this balancing mass, and 255 degree, that is 260 kg. So initially this is the midpoint is assumed as 0. So from the point A in the right side direction, because the mass is acting on the right side, so that is one of the assumption. So before this graphical method, we have to calculate some values m1 into r1. M2 into R2, M3 into R3, M4 into R4. That is the centrifugal forces of the each mass. So that is a 40 kg, 45 kg meter, 60 kg meter and 78 kg meter. So from this value we can draw the vector diagram. So from the point A, the centrifugal force of mass 1, that is 40. So from the point A, draw a line horizontal for A to B 40 mm. So in the scale we can fix the scale values. 1 kg meter equal to 1 mm. So 40 kg meter equal to 40 mm. So from the point A to B, so that is 40 mm length. The parallel line of second mass from the point B, that is the value of M2 R2 equal to 45 kg meter. The parallel of second mass, that is to be drawn, and the third mass is 60 kg meter. From the point C we can draw a line that is that should be parallel to the third mass, and the fourth mass, that is 260 kg, the value of M4 into R4 is 78. That line should be parallel to the fourth mass. The closing triangle is must. So for this, from the point E to A we can draw a line. So this is the distance of balancing mass. So that distance should be measured. So that is 23 mm. So 1 kg meter equal to 1 mm. The same thing here also, 1 kg meter equal to 1 mm. So m into 0.2 is the radius of balancing mass. Already it was given in the question. So m into 0.2 equal to 23 kg meter. So the 23 kg meter is 23 mm in the vector diagram. So from this vector diagram we can find the value of balancing mass, that is 115 kg. So the angle is to be measured. So the angle is 21 something. So 21 point something plus 180 degree. So finally we can get 201 degree values. So thank you.